Good morning, everybody. I think we are live. Today, we are going to do something interesting other than DP grinds. I will have, I think, 2 to 3 lectures on linked list mastery. We will try to solve all the linked list and singly, doubly, circular linked list questions on LeetCode in 2 to 3 lectures maximum. And through this, we will try to build up an approach or a generalized approach to solving linked list questions, no matter what kind of questions come. So, welcome everybody. Let's get started. So, I will be filtering by topics linked list and let's say doubly linked list as well. And then I will try to filter it by difficulty. So, we will go through every question one by one and we will try to, there are not a lot of questions. I believe maximum 30 to 40 questions and we will solve all of them one by one. Let's get started with the first question. It says, march to sorted lists. So you are given the heads. Uh, Before starting any linked list, before starting this series, let me try to explain you what a linked list is. So, linked list. So I believe that you know what an array is. Array is just, let's consider that this is the RAM. And RAM has a lot of cells. Let's say if it is 8 gigabytes in size. So the first address will be 0 and the last address will be 2 to the power, I believe, if it is 8 gigabytes, so 2 to the power 3 into gigabytes, right? So kilo mega giga to 30. This -1 will be the last address. I will tell you how to arrive at this calculation, but it's basically, let's say a, it's a 20 bytes size. So it will be, if it is byte addressable, then I will have every byte for one cell. So there are 8 gigabytes. So 8 into giga, and then we have bytes. So let's say 20 byte cells, 20 byte size. That means I will have address from 0 up to 19. Usually the size is a power of 2. So let's consider 16 byte size. Then the size will be 0 to, I mean, the addresses will be 0 to 15. Now, if we have an array, let's say I have a 16 byte size RAM. The total random access or primary memory of our system. We can definitely, of course, some of the sections will be taken up by system processes, operating systems, that are currently running programs, background processes, and so on. So we will have a limited size in the RAM. Let's say I declare an array or of size 4. That means 4 bytes, but integer take 4 bytes by itself. I don't take 4 bytes. Let's consider that the size is 512 bytes. Let's take a bigger size. So you see 4 integers takes 4 into 4 bytes. Every integer takes 4 bytes. So 16 bytes will be assigned. Now this 16 bytes can be assigned anywhere on the RAM. Let's consider that it gets assigned from 0 to 15. Of course, in this case, the last address will not be 15. So 0 to 15. So you see, and let's say I started inserting elements. Let's say ARR of 0 equal to 10. That means 10 will be stored in the first address. So, and if I say ARR of 1 is equals to 30, that means 30 will be stored in the first address. I mean, first index. You see that every element is stored one after the other physically in the memory. So you see, if you have access to one element, the next element is just beside it. So you don't have to go and scan the entire RAM or a particular section in order to access the next element. So if you have an access to one element, the access to the next element happens through constant time. I hope I made myself clear. So this is the case with arrays. So a contiguous memory location is allocated for a given array, and random access becomes fast. I will tell you what random access is. Let's say I want to access ARR of, let's say the size is 20. And let's say I want to access ARR of 15 directly. Now, ARR, we already know the base address when we declare the array. So base address is 0 in our case, right? Now, I want to calculate the 15 size. So it will be 0 plus 15 multiplied by size of one element. So 15, 0 plus 15 into 4, so 60. So we can directly calculate the memory location or memory address of where this 15th index element is present or the 16th element is present in my array. So we don't have to scan through this like 1, 2, 0, 1, 2, 3 up to 15. No, we can directly go to the memory location. Like in computer architecture, if we know an address to a particular address of a particular memory, then we can access it in constant time. So give me the address, I will just go to the address, pick up the element, or read, write, whatever. I hope I made myself clear. Now we are going to study about a new data structure that is not arrays. This was just an array recap. Now, say, let's call this array recap. Now let's go to linked list now. So linked list is such a data structure in which the elements are not stored in contiguous fashion. Like let's say this is the memory. Let me copy this. So you see, let's consider this is the RAM of 8 GB. So if some element is stored here, let's say, let me take a different color. Should I take yellow maybe? Yeah. If some element is stored here, can I take in this? If some element is stored here, that it is not necessary that the next element will be stored beside this. This is not necessary. It can be stored here. The third element can be stored before the first element. So first, second, third. The fourth element can be here, right? But how do you keep track of elements then? So what I will do is make a special kind of data structure. In that, let's say I want a linked list of, yeah, let's say I want a linked list of integers. What we will do is with an integer, let's say struct, we will take a structure. We declare struct by in C++ we or C we can declare structure by struct keyword. So we'll say, let's say we usually call it a node, the name of the structure. You can call this anything. You can call it the linked list of integers. You can call it the list node. You can call it linked node. We usually call it linked list node or node. Now we wanted a linked list of integers. So of course I will need an integer. We call it, let's say, integer val. And with this integer, I will have one thing else. So address of next node. So the first node, so this first node, let me take a laser. This first node should have the address of the second node. That will tell me how to go from first to second. The second will have the address of the third node, and so on. So every element will contain the address of the next node. Sometimes it contains the address of the previous node as well. That is called a doubly linked list. Let's focus on singly linked list as of now. Singly linked list means I will only have address to the next node. Doubly linked list means I will have address to the next node as well, previous node as well. Of course, that the last element does not have a next node. So we make it point to null. Usually the zero of a RAM or a general null pointer you can you can assign. Okay, so the so what we do is this address of the next node. Of course, it's an address, so it will be of type node star. Mm, It's the ADTR. For example, if you know, if you have studied basic pointers, you know that if integer a is 20 and I want to know the address of a, there is an address of operator int star ADTR is equals to address of a, right? So similarly, we want an address to a node, so we say node star ADTR. I hope you understand. I can just show you how this works. For example, let's go to a general file. Say int a is equals to 20, and let's say int star p is equals to address of 20, and let's say I want to print this. So you see, this is an address of a memory. It is an hexadecimal format, but if you can easily convert it to into binary and then decimal. I'm not teaching you how to convert an hexadecimal. You can try converting this. Everything that comes after 0x. Should I zoom this a little bit? Yeah. Everything that comes after 0x is the address. 0x is just a notation for hexadecimal. Like 0b is a notation for binary. Like I can write 0b and then 11010110 whatever. Of course, there is a notation for octal as well, which start with a 0. So hexadecimal we start with a 0x. Uh, Binary we start with a 0b, and so octal we just start with a 0. I hope you understand. So similarly, we like this. We Every node contains the address of the next node. So for example, let's say I made a node. So let's say this is 10 and it contains the address 55. So that means at address 55, let's say this is at address 21. So at address 55, let's say I have a 30 and let's say 21. So that means at address 20, sorry, not 21, let's say address 23, I have a value of 55 and let's say 100. So and at 100, so these are memory addresses. These are memory addresses. And address of 55 means it will point like this. I mean, not exactly point, I can say, wait. So it will just point to this node itself, not the value. The 100 will, uh, sorry, this will not point to this. This will point to this. This will point to this. 23 means this will point to this. I hope you understand. So you may have seen some diagram that denotes it like this. So this is what a general linked list looks like. A singly linked list looks like. Most of the questions we will deal with will be based on singly linked lists only. I hope I made myself clear. Now, there are some basic operations that we want to do with linked lists. Like if you have a linked list, uh, how can you print that linked list? Like let's say I have 5, 10, 15, 20. How can I print those elements? Of course, I have to go through every element. Of course, this will point to null pointer. So which denotes that there is no next element. So there, let's say we want to print the elements of a print linked list. So what we'll do, we go to every node, print it, and go to the next node in a recursive fashion. Like as long as I don't get a null pointer, you can do it through a while loop as well. As long as I not get null, print the element and go to the next element. I will show you how that works. For example, let's consider this. Where is the arrow? Let's say I have a linked list for let's say node. Let's call it linked list node. So it will have a value, and let's say it will have a star. You can call it link address. People call it next. So it's basically a type that shows that it's connected to the its address to the next node. So I have created a linked list node. Now we can make stuff like I can say that let's consider this as the let's say A, like first node. You can say I don't have much charge in my phone. We connect some sort of charger. I think I do have enough charge on my laptop. I'm audible. Uh, yeah, I hope it's okay. So where were we? We were on the coding screen. So I can just pass in 20. I think a new operator will work, but then I have to say that default constructor. Okay, I will explain you what this is. So you see, this is a default constructor that is used to, for, and it gives me the first node. So I can just say that print the first node. Now it should print 20. So what we have done is I have made a node with the value of 20, and then I'm printing that value. Of course, I can have let's say I want the next of the first node to point to some other node. So I can say that first node next equal to, let's say this returns me a new linked list node. Let's call it 30. I think I call it next, right? Hmm, let's make a new node first with a value of 30, and I will make it go to the second node. So you understand that the next of the first node is going on first. Okay, there's a spelling mistake. So you understand that I've made a second node, and that second node has the next as pointing to null pointer. But I've said that first node's link will point to the second node. Okay, let me show this to you on iPad. So what I first did is made a first node with a value of 20, I think, right? And then I made a second node with a value of 30. And now I said that the first node, and this is called second node. Now I said that the next of the first node, so the address present here will point to the second node. That's what we have done. So we made a first node, we made a second node. You see, when I first initialized, I made a first node, it automatically set the next of the first node to be null pointer. When I made a second node, it automatically set the next of the second node to be null pointer. Next, I said the first node next will not be null pointer, so I reassigned it to second node. Now I can just go, like, either I can directly say second node dot value, but let's say I want to go to second node through first node. So what I will do, I will go first node dot next. This is an address, and then of that, what I get is the value. This should be able to print 30. Let's see. You see, we get 30. I hope I made myself clear. So, uh, of course, there is a way, like, let's say I have multiple nodes. Let's say a third node, maybe. Okay, so let's make it 40. First node, next is second node, and let's say second node, next is third node. Now I can go either first node next, first node's next value. This should give me 40. I hope you understand how the chaining part works. Now let's say we have a lot of nodes. We don't know. Let's say we don't have three nodes. We have a series of links, and I want to print every value. So what I will do is first I will start a dummy pointer that will point to the first node. Now I will say while this dummy is not equal to null pointer, I can just print dummy's value and proceed dummy to the next element. So what this will do is first it will, let me show. So what I've done, let's say this is 40. So what I've done, this is the first node, this is the second node. Pointers are automatically assigned. Now I said that, okay, let this be a dummy, point to the first node. Now let's say I then print the value, and then I said dummy is equal to dummy arrow next. So what is dummy arrow next? Dummy arrow next is second node because dummy is now the first node. So dummy is next points to the second node. So let's make dummy be equal to the second node. So that's what we have done here. Dummy equal to dummy arrow next. Let's see the output. It should print 20, 30, 40. As you can see the output, it's 20, 30, 40. So I explained you how to print nodes, print the values of a linked list. Now let's try to solve some questions. There are some standard techniques that how to reverse a linked list, how to print elements if they are equal to something, how to remove a node. We will go through all of them through questions. Let's go to them. First, it says merge to sorted lists. Is there any easier way to? mm, no, there is no easy question of just printing the values of linked list. Uh, Before coming to this question, I think I should let me explain you some terminologies. Usually, let's say this is the first node. Usually, the first node of a linked list is called the head, and usually the last node is called the tail. Simple snake analogy. Uh, Usually, a linked list is defined by its head. Like, for example, if you have a linked list, if you know the head to this, you already know every element in this linked list. Like, if you know this head, you can print every element. You know the links. You can modify the linked list. You can do whatever you want with the linked list, like printing. If you know its head, because if you know the head, you can assign some dummy to this head and then maybe traverse through every element because every element of a linked list, or should I say, every node of a linked list is uh, contains the address of the next node. So it's like if you know the head, you know the entire link. Now, we will try to solve this question. It says march to sorted lists. So let me explain you this question first. Let's say I have two lists, one, two, five, and let's say three, four. So this is just a special diagram. It only, okay, this in this linked list format will be like this. A node contains a one, node contains a two, node contains a five, and this is null pointer. I'm showing null pointer through ground symbol of, of electronics. And let's say this is the head one, and let's say this is the head two. Okay, so 3, 4 will look like this, and this is the head two. So you see that if I know head, like this diagram that has been shown here, I think it's 1, 2, 4, and 1, 3, 4. So 1, 2, 4, and 1, 3, 4. Right? Let's take our one only. Let's say 1 to 5. Uh, So we are given two heads. Let's stick to our example. So we are given two heads, 1 to 4 and 1 3 4. We want to make a new linked list. So I want to make a new linked list that is like this. That will contain all the elements 1, 2, 3, 4, 5, and all the elements will be sorted. Like I know that the first linked list is sorted. I know that the second linked list is sorted. Now I want to make a new list such that the final list is sorted. If you have solved the question merge to sorted arrays, this will be very easy. If you have not solved it, I will do that question just now. Uh, if you have solved it, you can skip this section if you are watching this on recording. And if you are watching this live, then you can take a small tea break. Let's see how the stream is running. Uh, is now the first node. So dummy is next, points to the second. Okay, it's running well. So let's try to solve the question. If you don't have a linked list, you just have a two sorted arrays. And I want to make a new array such that uh, it's the sort it contains both elements of both the arrays and it's sorted. So that same logic we will use to solve this question. So what I will do is let's make a new file, merge to these two sorted arrays, DSA. Let's say let's take two arrays in input, n comma m. Let's say a1, a and b. Let's say. Forget about these templates and how I am, and ignore the part where how I am taking inputs and all. Just focus on the logic of this code. Okay, so we have two arrays, right? So a1, I mean in our case it's a and b. And let's say 1, 2, 3, 7, 9, 10. Let's say 1, 5, 8, 14, 26, 31. Now I want to make a new array. So the best way will be, let's say, take a big array. Let's say this is of n size and this is m size. So this is m plus n size. And I will compare these two. Which one is bigger? I mean, which one is smaller? Okay, if they are equal, so do any of them. So shift this on the next time and this insert this one here. Now I check which one is smaller, 1 and 5. Okay, 1 is smaller, so take this one. Now out of 2 and 5, which one is smaller? 2 is smaller. Put 2 and increase this. Like it may look like pointer, but it's just indices. I will show you how to do this in code. So you understand that initially there are two pointers at the beginning of the array. Which one is smaller? Take that, increment that. Which one is smaller? Take that, increment that. Of course, it's possible that there is nothing in the first array. In that case, I will just take the second array. I hope I made sense. Like in the end, let's say this first pointer has reached the end and the second pointer is maybe here. Then there is no way to compare its two elements. So in that case, I will just keep on inserting the elements of the second array. So of course, if both of the elements are available, then we compare. If one of them is not available, then we don't compare and just move along. So I say, let's say I make a new variable, vector of integer of let's say c of size a plus b, I mean m plus n, right? And I say two pointers, while let's say two pointers, let's say int p1, I mean pointers means indices. So I1 equal to 0 and I2 equal to 0. I can call it IA and IB. Okay, and now I say while IA is available or IB is available. I mean, if so, this means that uh, I have elements in either of the arrays that have not been put into C yet. I can just not define C as the size. We can just say that if A of IA is less than. First, I think IA will have to be available. If IA, so let's say if IB equal to M, or let's say IA, A of IA is less than A of IB. So I will check for IB only if IB is not equal. I mean, like in which case I will be putting, let's say, so C dot pushback uh, A of IA. When I will put the first pointer's element in C, either the second pointer is not available or it is available and IA is smaller. I mean, A of IA is smaller than B of IB, right? I hope I made myself clear. So these are the two conditions. So either IB is not available, like element of B is not available. We have already exhausted all the elements. Or A of IA is less than B of IB. In that case, we push back A of IA. If IA is not available and A of IB, B of IB is less than A of IB. In that case, we push B of IB. And of course, I have to do IB plus plus. I hope I made myself clear. In these two cases, of course, both of them will not be MNN because otherwise this will break, right? Let's try to print C. So let's take a new create problem. So let's say 2 size and 2 comma 3 size. Let's say first is 1 comma 5 and let's say 2 comma 4 comma 7, right? Uh, wait, I'm missing some input. Still expecting something. Wait, let nm. Let's try to run this on the terminal. So 2, 3, 1, 5, and let's say 2, 4, 5. Is it taking input forever? Okay, then we have a problem. Wait, if IA is less than n, equal to n, IA plus plus. Mhm. What will make sense? This will not be n, but let's see. Mhm. IA is okay. I think less than equal to will also work because okay. Where is it causing problem? Let's try printing this. It's correct. Okay. Okay. Now long stuff is problem. This size is failing for some reason. What is this error? Let's try to run it normally. So 2, 3, 1, 5, 2, 4, 5. What if I put this and? That's just not a solution. One, 1, 2, 4, 5. Yeah, but it's missing. If I can just do this and later I can just do for less than n. Just do if any of the leftover elements is there. That is one way of solving this. Well, let me explain you this solution then. So what we have done is, if both of them are less than, then in this case I don't need this one. So both of them are available. Uh, that means I will check and increment. If at least one of them will fail in this end. If A fails, then in rest of the elements, if B fails, then this any one of these, the rest of the two whiles will work. I hope you understand. This code will definitely be available. I want you to understand this logic that what we have done here. Next, we will do this in terms of linked list. So in this linked list case, so I have two heads pointing, right? If the element at the first head is lower than the element at the second head, what I will do? I want a new linked list such that uh, I can just call my original problem with this statement that, okay, let's say the A1, let's say head 1 will go to here, and I want the answer for this now, right? And this, whatever result it returns me, a new linked list of merging these two sorted lists. And and want the answer to that, and I want my next of the first pointer to point to that. I will explain you. So this is our recursive approach. Let's say one pointer. I think it's for 1, 2, 5, right? And it was 3, 4. And let's say we have two pointers. What are we doing? We are comparing the values of these two pointers. then we have seen that 1 is smaller than 3. So what I will do is shift this pointer up, and I will say that this first pointer's next will be the result of this. So I will call the same function for this. You see now 2 is smaller than 3. So I will say 2's next will be the answer to this, right? Now I will compare 3 and 5, and 3 and 5 when I compare, I see 3 is less. So I will say that the next of 3 will be the answer to this. Wait, uh, right? Now 4 and 5 I will compare, and I will say that the answer to the next of 4 will be the answer to this. Now you see I have only one linked list, and that will return me this, its own pointer. I hope you understand. So either one list will get empty or the other. Both of them cannot get empty, right? And then I will return that pointer. I hope you made sense. I hope this diagrams make sense. So I will say that, okay, let it pass, and this node's next will be the answer to the rest of the world. And there will be a base case when one of the list is empty. I know the rest part of the remaining list is sorted. So I will insert that. So you see, while backtracking, 5 will be returned to 4. The address of 5 will be returned to 4. So 4 will start pointing to 5. Now 4 will return itself because that's the answer. That will be the uh, address. That will become the next of 3. And 3 will return itself. And that will become the next of 2. I hope that makes sense. So what I will do is check if any of the list, if list 1 is null pointer. Should I zoom this a little bit? Yeah. I will say if list 1 is a null pointer, return list 2. If list 2 is null pointer, return list 1. Otherwise, check if list 1 dot val is less than list 2 dot val, then I will say list 1 next will be, I will call the same function, but I will pass list 1 next, and I will pass list 2 as it is. I hope I'm making sense. Of course, there will be another else if list 1 dot val. So this is greater than. In this case, I will say list 2's next will be, and I can say list 1. Let's try to run this. Okay, in the end, I will just return what? Should I make a new function? Wait. Okay, then I will just return this one. In this case, I will just return a list two because list one next has been assigned to the rest of the world. And this will not be accessed ever. So wait, if there's a less than equal to part as well. Like I can, if it is equal also, it's not a problem. Okay, we have so this is accepted. Very simple solution. So what we have done is, let's say both of them are null. If list one is null pointer, we return list two. If list two is null pointer, return list one because the rest of the part is sorted. Now I compare if two elements, compare the two elements, which one is smaller? I will say that smaller's next will be the answer to, I will call the same function and I will say pass in the smaller's next. So this part and the bigger list. And then I compare these two and say which one is smaller. Let's say this one is smaller. So I will pass this smaller's next. So that's the new head and this. And one of them is bound to be empty, right? And that will just return itself. This last return will never be accessed. So I hope you understand this question. Okay, how long is the stream running? Today's main objective was to make you understand the basics of linked lists. Okay, it has been 1 hour. Let's see how the stream is running. Okay, how long is the stream running? Today's main objective was to make you understand the basics of linked lists. Okay, let's try to solve the next question. Remove duplicates from a sorted list. So we just want to remove duplicates, and if it is sorted, then the duplicates are bound to be one after the other. So I will check that if my value is equal to my next person's value, then I have to skip that node all by itself. So what I'm doing is, let's say, there's a one, it's one, and there's a two. Now you see these two are equal. So I will say, let's say, okay, dummy node's value is same as the dummy node next value. In that case, what I will do is, I will point my dummy nodes next to dummy dot next dot next. You understand? So once next will not be the once next. It will be once next will be once next's next. That's what I'm doing. So I will just show you the code. Uh, Have I solved this before? Yeah. Okay, this is a long one. Uh, okay, this is a very old solution I've solved. Let's forget this. Let's reset. So what we will do is, uh, let's say if head equal to null pointer, then we return head. Okay, because we have in linked list questions, you always have to take care of null pointers because the test cases are designed that way usually. Now, if it is not null pointer, that means I have something. So I will check. I will first say, let's make a dummy. Let's make it point to head. And let's say while this dummy is available is not equal to null pointer, and dummy's next is also not a null pointer. Otherwise, how will I check? the value for the next node. Then I will check if I, but we can have multiple. So I can just say while uh, like let's say 1 1 1 1 1. So you see, we have checked. I can just say that if dummy val equal to, then I can just say now see it will check for the two ones. If they are equal, it will point you to the next one. But we are not actually taking care of memory this time. Like this will always remain. So we have to say that let's say list node star blob is equals to dummies next, and have to free this, right? Otherwise, you see, it will remain in the memory as a garbage. In C++, we don't have default garbage collection. You can skip the garbage collection part, but it's a good practice. So I've said that dummies next is dummies next next. If this is not the case, if they are not equal, then I can just go dummy equal to next. And we'll do this until it's available. So return the head itself. Like the dummy has done all the work. If there is no free function, I have to check this later. And that's how it was done. It's getting accepted. I will make a Google search for this free. Okay, wrong answer. 1 1. Okay, I understand. So what it has done is it is equal to. So it has pointed to the next. Now it has went up to the next. So I want that, or as long as they are equal, I want to continue doing next. As long as dummies next is available, let's use this test case and see. Yeah. So we want to do it recursively. Like as long as it's not doing, let's make it jump. So I will explain its code. So what we're doing is, of course, I have to say, even though this is not necessary. So I'm saying that, let's say this is the first node, dummy, and this is the next node, dummy is next. Now I want to say that maybe if this is equal, let's make me point this to this. But now these two are also equal, right? But that I'm not doing. So this now in that after that, dummy will be dummies next. So this will point to this, and its next is null pointer. So 1 1 will remain. So we want to say that as long as dummies next exist and dummies value is equal to its next value, make it jump, and do this recursively, and then check again. Is this next available? Okay. And are they equal? If they are, then this new next is again the next order. Try to run this through your head a little bit. Okay, max batteries. Ah, okay. So you have understood how to remove duplicates from a linked list. Let's go to the next question. Okay, how long has the stream been running? Only 1 hour. We have a lot of time to go. Let's say linked list cycle. Okay, this is a very good question. And through this question, I will try to uh, uh, teach you how to, let me reset. I will teach you how to, I will teach you a new algorithm. And that's a very useful algorithm and applicable in a lot of linked list problems or similar problems. Let me teach you the algorithm first. This is, so cycle detection is called. Now, this algorithm, cycle detection that I'm going to explain now, is not only applicable to linked lists, it is applicable to any data structure that can have cycle, like graph. Of course, trees don't have cycles. So, in any data structure, where you think there is a cycle is forming, and you have made a graph out of it or some sort of linkage system out of it, this algorithm is applicable. This is called Floyd-Warshall cycle detection algorithm, and it's very smart. And I will teach you how it works. Let's consider this is a let's say this is a sequence of nodes, and I want to detect cycle. Not only does it help to detect cycle, it also tells me where this cycle has started, which is this point. I will teach you all the ways. So what I will do, first I will make two pointers. One pointer is called the rabbit. The one other pointer is called the turtle. Industry standard names, not given by me. Now what I will do, I will at every location, I mean at every iteration, I will make a rabbit jump by 2 steps and turtle jump by 1 step. So in the first iteration, turtle will go here. Uh, Turtle will go here, and the rabbit will go here. You see, rabbit has jumped 2 steps. Should I make this? Uh, let's make it T. Okay. So in the first, so T is equal to turtle, and R equal to rabbit. Okay, in the first iteration. In the next iteration, what will happen is T will go here, and R will go here. You see, it has jumped 2 steps. So 1, 2. At first was 1, 2, 2, 1, 2. Next again, the rabbit will go 2 steps, 1, 2. And the turtle will go one step, right? Next again, the rabbit will go two steps. I want you to understand what is happening. So rabbit will come here. The turtle will come here. You see, they have joined. So you see, if there is a cycle, the rabbit is bound to meet the turtle at some point. Otherwise, it's impossible for them to meet. Because in the first iteration only, the rabbit has went away by 2 and the turtle has gone 1. I hope you understand. So this was an even length cycle, right? Let's try to check for one odd length cycle as well. So observe this carefully. RT, right? R will go here, T will go here. Next, R will come back here and T will go here. Next, R will go here and T will also go here. Do you understand that it's always pointing to that node that is hitting the uh, point from which the cycle starts? Let's take it for one more example. So RT initially, T goes here, R goes here. Next, R goes here, T goes here. Next, T goes here and R goes here. Next, T goes here and R goes here. Wait, it's not happening now. So you see, in this case, the R and T are not pointing to that position where it's doing its work. Let's make it do it again. So RT. So T goes here, R goes here. Next, R goes here and T comes here. Next, R goes here and T comes here. Next, R goes here and T comes. Well, it detects the cycle for sure. But how do I find out this point where this cycle occurs? There has to be a backtracking step. Let's run it one more time. Let's say this is the point of intersection, right? That means, let's say I make another P point here, and now let's start running. So P comes here, T comes here, P comes here, T comes here. So that was the trick. Like the distance of base to the hit point is the same as distance from intersection of RT to the hit point. Let's take it like one more step, like one more big example. Let's take this graph, RT. What will happen is R comes here, T here, R comes here, T here. Now R comes, let's make this the direction. So R means 1, 2, 1, 2, 3, 4. Let's say R4, 1, 2, 3, 4. T here. 1, 2, 3, 4. R and T will meet here. So this is the meeting point of R and T. Now you see what is the distance of the base point to this? 1, 2, 3, 4. This is same distance. 1, 2, 3, 4. I hope you understand. So this Floyd Warshall cycle detection algorithm helps me detect if there is a cycle. That means R and T will meet, and the point where cycle starts. So that is a potential way. If I can find where the cycle starts, I can just remove this pointer, and that will end the cycle, right? Or I can do not directly catch it here. What I can do is make this RT run one step less. So it will come here, right? And break this link. You understand? So that will get rid of the cycle in this directed is directed cyclic graph. So I converted it into a directed acyclic. I hope I made sense. So I will just implement this only. So I will say int. Okay, let's check the string. Cyclic. But I think I made the title wrong. First mistake. Sorry, guys. Uh, so we are on this. So we will start with a rabbit. Both will start from head. I will say while. Of course, if there is no cycle, the rabbit will reach the end while rabbit is available. So I will just make rabbit. Of course, rabbits next will also need to be available in order to make rabbits next possible. So and I will make turtle jump by one step. Okay. So if return true, let's try to run this. Looks like the internet is a little slow. Should I refresh? Let's refresh this page. Of course, the codes for every question will be available. Should I refresh? Okay, some gateway error. Are the other websites working well? Then it will help me understand if, yeah, it's working well. It's not working for some reason. Is the default website working? Like code.com. What about Codeforces and Codechef? So Codeforces, the Codeforces is also working. Happy New Year season. What about Codechef? Yeah, Codechef is also working. Only LeetCode is not working. In that case, we have to end this stream here. Let's uh, let's continue. How many hours have passed? 1 hour 22 minutes. So we will keep our stream up to here. We have only solved two questions, I think. Hmm. Yeah, I believe we have solved. No, I think we have solved three questions. One is merge to sorted lists. We have learned about how recursion is working on that. We have solved removal of duplicates from a linked list, and we have also solved cycle detection. We have not only solved cycle detection, we have learned how cycle detection works and how to find the point of, find out the point where the cycle is, and even possibly remove cycle from a directed acyclic cyclic graph. Now, of course, you can repeat this process continuously as long as there is a cycle. That will be a brute force way. I hope I've made myself clear, and I hope the cycle detection part is clear. If you have any questions, you can let me know in the comments. Thank you very much for watching. Like, share, subscribe, and jargon only if you find value in this channel. Have a great day and good morning. We will uh, uh, continue our linked list mastery and the DP grind from our next video. I think one of this. Linked list mastery will not take more than 3 to 4 videos, I believe. Maximum 5 to 6 videos. Like if you only solve 3 to 4 questions every stream, there are about 40 questions on linked list possible. So not a lot of videos required. DP, I'm trying to make out a journey so that every possible DP questions is solvable. I hope.